Hey guys, Ed here with the summer's most anticipated installment in our Johnny 5 build, his tiptoe mechanism. This subassembly is an eccentric actuator mechanism that gives Johnny the ability to stand on his tiptoes when he needs to get a better view, intimidate enemies, or dance to disco tunes. When he's finished, he will be quite heavy, 300 or 400 pounds, so the parts we'll be making today are all pretty stout, mostly made of steel. Not a whole lot has changed externally since the last time you saw him, so let's dive on in and get started making those parts, because there are a lot of them, like always. First parts we'll be making from mild steel on the Tormach 1100M. These are his left and right tiptoe arms, which link the motion between these eccentric discs to the cam on the tiptoe tube. For Op 1, simply decking the backside and drilling some holes that will be used for fixturing in Op 2. For the main op, I designed this aluminum fixture that will work for both the left and right hand parts. That includes relief for backside chamfering, which I didn't end up doing, and tapped holes to hold down the stock, as well as large waste areas that we don't want flying loose as they're parted off. First up, profiling. Most of that is OD profiling, but we have a bit of a slot there on that upper waist piece using the 3-flute die-jet high feed mill from Tormach, finishing that outer contour with a 1/4-inch 4-flute end mill from Lakeshore Carbide. Then we can get rid of that waist piece before continuing with the rest of the machining. Then roughing out this center clearance area using a 5/16 Lakeshore Carbide end mill and a 3D adaptive toolpath. John also made a pair of these on the UMC 750, and we'll have a video on that out very soon. Finishing the flat face surface using the same tool and a 2D contour toolpath with roughing passes and stock contours selected. Card here to Johnny 5's page on the NYC CNC site, where you can check out the speeds and feeds and cam in more detail. Then using a 2D contour and a ball end mill to come in and clean up this inside fillet in one pass. And I was thrilled with the way that turned out. Nice quick toolpath and an easy way to get a good looking smooth inside finish when you can. You'll notice for cleaning up this face, I threw on a little strap clamp so I could take out that screw, which would otherwise be in the way. Facing with a facing op, just roughly aligned to the angle of that face, then finishing the pivot hole using a boring op. And now that that's done, that screw can go back in and the strap clamp can come off. And again, adding a couple of these small strap clamps while we slot out this large center section, which will accept the eccentric disc. Again, that's the die-jet high feed mill with a 2D contour toolpath set to ramp. Finishing that inside profile with a boring op and a 1/4-inch 4-flute end mill. Roundness on that ended up being great, well within a thou. Last step for these is creating the slot at the tip where the tiptoe cam goes. For that, all I did was cut a couple of these custom parallels on the laser that will hold the part at the right angle and probe my work coordinate system off the left side of those. These 1/4-inch aluminum side plates form the structural backbone of the tiptoe mechanism. Made these essentially the same as I made the boomerang plates on his track drives. Card here to that video if you haven't seen it yet or need a refresher. Next up, we have a couple of small plate pieces to make for the motor mount. The width on this one is nominal, I think 3 inches if I remember correctly, so I was able to get away with just holding it in some smooth jaws and cleaning up the saw cut edges. This smaller piece was more of an odd size, so I just used some of the same stock and slotted the part out window style after finishing the internal features. This elevated window machining with tabs is a technique that I'm liking more and more lately as a lazy person. I mean, as an efficient machinist. Those tabs are triangular, of course. Next up, the eccentric discs. These are also mild steel and mount to the large sprockets in the eccentric drive. Here, using a 1/4" Lakeshore Carbide fireplug rougher to slot out the tiptoe cams from 1/4" mild steel sheet. That is also a 2D contour toolpath set to ramp with tabs. And since this has such a large unsupported area, using a couple of hockey pucks to dampen vibration. Those cams attached to the tiptoe tube with these aluminum cam rings, also slotted out. We chose to use these 3" oilite bushings rather than the slimline ball bearings called for in the original design. And the tiptoe tube, being made of aluminum, is far from an ideal bearing surface, so we lined the bearing areas on that with roughly 1" wide strips of turkite, which is a brass impregnated Teflon sheet bearing material commonly used for the sliding surfaces on machine tools, including Tormachs. Now, over on the Haas TM3P, making these mild steel linkages, which link the tiptoe cams to the caster's upper A-frame. These are what transfer that tiptoe motion to the caster end of the robot. Using our dual station mod vices to run op1 on the backside and the fixture for op2 on the front side. Facing the backside at an angle, not totally necessary, but it ended up making the finished parts look a little prettier, which is always nice. Spotting and drilling the holes which will hold the stock and scrap pieces again. For these I slotted halfway down during op1, so I was able to chamfer the backside before flipping the part and finishing the other side. For these I'm using a Lakeshore Carbide roughly 1/4" high feed mill. Now flipping the part using dowel pins for alignment, bolting it to the op2 fixture, facing again, this time aligned to the contours of the part. Here I'm using a 1/4" end mill and a both ways 2D adaptive to get rid of a small waste area at the front, and I appeared to have made a small boo-boo with my containment sketch. So after a small tweak to that sketch and a trip to the shrink fit machine, we can finish that up and move on to finishing slotting out that part with that high feed mill. Because we have such a large unsupported area at the middle of this part, I modeled in this tab on the top side so that I can finish contour the bottom side of the part, add a strap clamp, slot off and remove that tab, and finish the other half of the contour on the top side. And I am of course leading in and out on the curved areas, so that helps hide any lead in and lead out witness marks, and if I do get anything, it's in an easier spot to blend on the Scotch-Brite wheel. Assembly montage. Coming up next time, my first 5-axis part, which was terrifying, but turned out great. And we're continuing our way upward toward his middle and upper torsos. Thanks for watching. See you next time.